Hi, this is the second lecture session on the subject Operating System Design of Module 1, Part 2. I'm Seema Safar, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. The contents that will be covered in today's session will be characteristics of modern operating system, traditional and modern Unix systems, introduction to the kernel, architecture of the Unix operating system. Let's begin the session. Let's begin today's session with the topic characteristics of modern operating system. Huge lines of code, huge number of unnecessary features are not only the features of or good characteristics of operating system. So we have to consider the designing concepts before to say that it is a modern operating system. Now the characteristics of a modern operating system is like listed as shown in the screen. You can see the first characteristics listed out as object-oriented design, right? In which object-oriented design in the sense that operating system creates the objects for each facility and each object has a set of operations to do. Now the second characteristics which is pinpointed here is multi-threading. An application or a program which is divided into a number of smaller tasks and these tasks are executed by the processor concurrently, then we say that these smaller tasks are going to be called as threads. You might be knowing that thread is basically a lightweight process. As you know that several threads will be sharing the same memory space, but processes do not do that, right? Now, number of independent threads in an application executed by a processor at a time is called as multi-threading. So that is going to be another characteristic feature of a modern operating system should have. Then we have the third point, which is symmetric multiprocessing. Now, what is symmetric multiprocessing? If a computer is having more than one processor, these processors will be sharing the memory and input-output facilities, and these processors will be sharing the same job for execution, then that system is called as symmetric multiprocessor system. So can you say what are the advantages of a symmetric multiprocessor? It is that it can improve throughput of the system and the reliability will be improved. It means if one processor failed due to the hardware problems, even it can execute the jobs with the other processors. That is what meant by reliability. Reliability is improved if you're using a symmetric multiprocessing. So that is going to be the third characteristics of a modern operating system. Now the fourth listed characteristics is distributed operating system. Why so? A distributed operating system is an operating system that runs on a network of computers. All right. Now the operating system, memory files, etc. are shared by the number of users in the network from the server. For example, if you suppose that you have 30 nodes which is connected by a server through LAN. All right, then the processor slots, RAM, files, etc. are shared by 30 users from the server. Here each user will be having or he'll be thinking that he's running on a single large system with one operating system. That is the essence of distributed operating system. So that should be the feature of or the characteristics of the modern operating system. And the final characteristic which is listed here is microkernel architecture. It should have a microkernel architecture. In the sense, what do you mean by microkernel? It is a minimal operating system that performs only the essential functions of an operating system. Now, system processes perform all other operating system functions. Therefore, the system processes means it will be acting as a server here. So that's it about characteristics of modern operating system. Next topic is about traditional and modern Unix systems. Talking about traditional Unix systems first. Now, the history of traditional Unix system. The first version of Unix was developed in 1969 by Ken Thompson of a research group at Bell Laboratories. Now, during the past 25 years, the Unix operating system has evolved into a powerful, flexible, and versatile operating system. Now, this serves as the operating system for all type of computers, including single-user personal computers, workstations, microcomputers, etc. Now, in fact, the success of Unix is due to many factors, including its portability to a wide range of machines, its adaptability, its simplicity, the wide range of tasks it can perform, and the multi-user and multitasking nature, and its suitability for networking, etc., etc. Now, talking about main features of Unix system. It has the ability to support multi-user and multitasking. It is portable and it has an excellent network environment. Flexible file system is another important feature of Unix, and it provides better security. Here you can see a picture on the left hand side and a right hand side. On the left hand side you can see Unix architecture. The architecture of Unix is actually divided into 4 layers: hardware, kernel, system call interface, and application programs or libraries. Now, what do you mean by a kernel? The kernel is the part of operating system which interacts directly with the hardware of a computer through device that is built into the kernel. The main function of kernels are to manage computer memory, to control access to the computer, to maintain the file system, to handle interrupts, to handle errors, and to perform input-output services, and to allocate the resources. Now, talking about the shell. Shell is the part of operating system. It is a software program which acts as a mediator between kernel and user. The shell reads the command, what you have typed at the command line, and it interrupts them, and it will be sending requests to execute a program. That is why shell is called as a command interpreter. Then we have the hardware part, which includes all the parts of a computer, like clock, timers, devices, parts, etc. Now, the outermost layer, as you can see here, includes Unix commands and libraries. This layer includes user-written applications using shell programming language and libraries of Unix. Hope you have understood traditional Unix kernel architecture, which is shown here. Now, moving on to the picture of the right hand side, which is modern Unix system. A Unix system that follows the designing principles and features of modern operating system is called as modern Unix system. As you can see in the figure below, in the figure the outer circles represents functions and an interface that may be implemented in a variety of ways. All right. Now let's discuss about the architecture of the Unix operating system. This picture depicts the block diagram of the system kernel. Now here you can see 3 levels. One is user level, kernel level, and hardware level. The 2 major components of the kernel include file subsystem and the process subsystem. This you can see in the figure on the left hand side and right side. You can see 2 boxes. One is file subsystem and the other one is process subsystem. And the system call and the library interface represent the border between the user programs and the kernel. System calls normally look like C programs, like ordinary function calls in C programs. And libraries map these function calls to the primitives needed to enter the operating system. Now this figure is taken from your reference textbook. Reference will be provided in the last slide. Talking about the file subsystem. Processes interact with the file subsystem by using a set of system calls like open to open a file for reading or writing, close for closing the file, read for reading from a file, write to a file. Then we have stat system call to query the attributes of a file, chown system call to change the record of who owns the file, which means to change the owner of the file, chmod to change the access permission of a file. The file subsystem manages files, functionalities like managing files, allocating file space, administering a free space, and controlling access to the files and retrieving data for users. Then we have device drivers and block input-output devices. Device drivers are the kernel modules that control the operation of peripheral devices. Block input-output devices are random access storage devices. Alternatively, their device drivers make them appear to be random access storage devices to the rest of the system. The process control subsystem is basically responsible for process synchronization, inter-process communication, memory management, and process scheduling. The memory management module controls the allocation of memory. So it is responsible for allocating memory to each processes. It makes use of two policies for managing memory. One is swapping and demand paging, which you have already studied during your graduate time. Now the swapper process is sometimes called as scheduler as well. Moving on to the inter-process communication and hardware control in Unix architecture. There are several forms of inter-process communication, ranging from asynchronous signaling of events to synchronous transmission of messages between processes. The hardware controller is responsible for handling all kind of interrupts and for communicating with the machine. Devices such as disk or terminals will be interrupting CPU while a process is executing. If so, the kernel will be resuming execution of the interrupted process after servicing the interrupt. So interrupts are not serviced by special processes but by special functions in the kernel called in the context of the currently running process. Listed are the reference textbook for today's topic. Thank you.